think about concavity from like a verbal perspective. So increasing, we know that this is increasing, correct? And that is increasing at a steady, steady, steady pace, right? The slope is the same all the way as this goes. Now, what if I said a graph is increasing, but it increases faster and faster and faster and faster? So think about making money. You're making money slow at first, and then we're making more and more and more, and it's faster and faster, and your money is growing faster and faster. What does that look like to you? Well, to me, it looks like this. It's growing, but it's growing faster and faster and faster as we go over time. So if something is increasing faster and faster and faster, is that concave up or concave down? Well, this is concave up, and CC up is a very, very accepted way of saying concave. It's just a lot to write the word concave sometimes. So CC up, concave up, we will all accept that. What if you're increasing and you're not faster and faster and you're not steady, but you're increasing, but that increasing is slowing down and slowing down and slowing down, like running a marathon. Like when I'm doing a long run, I start out kind of fast, but I slow down over time, right? So what does my pace look like if I'm running, but I'm running slower and slower and slower? Well, instead of staying steady, I'm going to run and I'm going to increase, but in a slower and slower and slower way. So we would see that this is concave down. So if we think about things that are increasing, now look at the slopes of the tangent lines on this increasing faster and faster and faster concave up. So if we're increasing, and look at these slopes, the slopes are getting bigger and bigger and bigger. Does that make sense? So if we're increasing and our slopes are getting bigger, then this thing is concave up. Whereas with the concave down, we have a very steep slope here at the beginning, but as we keep going, the tangent line slopes, those average rates of change, are getting like slower and slower and slower. Those slopes are getting smaller and smaller and smaller. So if we're increasing, but the slopes are getting smaller, then what we see is something that is concave down, right? They're getting more, they're slower and slower and slower, they're smaller and smaller and smaller. So that's how we can look at something and determine, is it increasing, decreasing, concave up or concave down, when we're thinking about, is it going faster or slower? All right, let's look at decreasing. If something is decreasing steady, it looks like this. But what if it's decreasing, but the decrease is bigger and bigger and bigger? Like that example of the hair loss we saw, where the guy had hair and then it was gone and then it was more gone and there was more gone and it was more gone. Okay, so how much hair does our guy have? Well, he starts with a lot and then he has less and then he has a lot less and then he has a lot. So it's going like this. It's decreasing faster and faster and faster. What shape do we have here? This one is concave down. So if you're decreasing and those slopes go from less steep, but we get steeper and steeper and steeper. So if we're decreasing and the slopes get steeper and steeper, then what we have is concave down. Whereas if we're decreasing, but that decreasing is slowing down, right? So we have something that's going down, but it's going down slower and slower and slower. What does that look like? So it's going down fast at first, but then it's decreasing, that's slowing down on its going down. What does that look like? That's concave up. So we see that we're decreasing, but look at these slopes. They're very steeply negative, but then they get shallower and shallower. So these are getting less and less steep on their slopes. So when you are looking at a table, you can actually determine two things. You can first determine, is this thing increasing or decreasing? And y'all did a very good job of that last time. But then what we can look at is, what is the average rate of change from this pair to the next pair to the next pair to the next pair? And by looking at those slopes, we can determine, is this an average rate of change that is getting faster and faster, or slower, or less and less steep? And then we can determine, is this thing going to be concave up or concave down? This can get a little bit tricky, but let's see if we can understand what's going on here. Okay, so let's look at our first problem here. So we have, as the x's are getting bigger, notice -8, this is the direction of the x's. As x's are getting bigger, what is happening to the y values? 10, 11, 14, 20, 29. Okay, this is definitely increasing, right? So we can see pretty easily that we are increasing. Now, I'm going to calculate the first average rate of change by hand so you can see it. What we always want to do is the second minus the first, and remember it's y2 minus y1 over x2 minus x1. So just kind of really quickly, we're going to do 11 minus 10 y's minus our x's, -6 minus -8. So the average rate of change from these, from the -8 to the -6x is going to be, let's see, that's 1/2. So that's not a very big average rate of change. Now what we do is we go to the very next pair. So you're going to use this -6 again, but here we're going from 14 to 11 and -4 to -6. So if we do our slope here, so we're going to do 14 minus 11 over -4 minus -6, and that's going to give me 3/2, so 1/2. So my slopes are getting bigger and bigger. They're getting steeper and steeper. Let's look at the next one. So here we're going to have 20 minus 14, that's 6. -2 minus 4 over 2, well, that's a slope of 3. That's even bigger. And if we look at this one, we're going to get a slope of 9/2, which is 4.5. So if we look at our slopes, we're going from 1/2 to 1.5 to 3 to 4.5. Those slopes are getting steeper and steeper and steeper and steeper. So let's think about it. We're increasing, but we're increasing steeper and steeper and steeper. What is that? That is concave up. So the average rate of change is getting faster and faster. So it is concave up. Let's try this next one. As the x's are increasing, what's happening to the y's? They are decreasing. So this one is a decreasing function. That's going to be the easier part. Now, let's really quickly kind of look at our slopes. 75 minus 100 is -25 over 5, so this is a slope of -5. Now, 40 minus 75 over 5 is going to be a slope of, let's try that again, a slope of -7, which is a bigger slope. It's a steeper thing. Then we can look at 0 minus 40 over, that difference is 5. Well, that's a -8. And then this one, -50 over 5, that's a -10. So do you see how the magnitude of these slopes is getting bigger and bigger and bigger? The magnitude is getting bigger. So we're decreasing faster and faster. And I always have to then draw it. Okay, we're decreasing, but we're decreasing faster and faster and faster. So it looks like that. So this must be a concave down graph. Everybody see what we're doing? Is this tricky? Yeah, this is tricky. This is really tricky. Okay, let's try the next one. Okay, as the x's are getting bigger, the y's are getting bigger. So this one is definitely increasing. And if we look at the slopes and take a minute to draw those in, I have calculated them ahead of time, and we can just very quickly see what are the slopes here. So the slope between these 2 points was 8.8. The slope between these 2 points is 5.14. The slope between these is 4. And the slope between these is 2.8. So we're increasing, but the rate that we're increasing is getting smaller and smaller. So let's see if we can draw that. We're increasing, but we're increasing smaller and smaller tangent lines. That looks like this, right? Because this slope is smaller than this slope. Okay, so this is the shape that we've got. So we're increasing slower and slower. So this is concave down. These are a little tricky, you can see. All right, last one, as our x's are getting bigger, you can see our y's are getting smaller, so this is decreasing. And I will give you all of the slopes from point to point. So this is negative 1.5, this is negative 2.1, this is negative 2.7, and this is negative 4.1. So you can see that the magnitude of those slopes is getting bigger and bigger and bigger. We go from a shallow 1.5 to a steep 4.1, right? So it is decreasing faster and faster. So how do we decrease but faster and faster? It must look like that, which is again concave down. All right, this is probably one of the hardest things to sort of think through, but it's something we need to understand. What is the connection between what is happening in the numbers and whether something is concave up or concave down?